Right, actually, slightly wobbly with the camera. A group of 7 students sit in random order on a bench. Find the number of orders in which they can sit. Well, how many arrangements can we make of 7 things? Well, that's quite an easy start, isn't it? We're looking for the answer 7 factorial from this one. 7 factorial on the calculator is 5,040. Beautifully written. Right. Cool, good start. The 7 students include Tom and Jerry. Find the probability that Tom and Jerry sit next to each other. Oh. Right. You know how this works now. We've changed this, haven't we? We're thinking of Tom and Jerry as one item, and then there are 5 more items. So actually we're considering how many ways can you arrange the 6 items. Does that make sense? We're thinking of them as one unit plus 5 others. That's how it's working. So that's 6 things altogether, 6 factorial. But Tom and Jerry could be Tom and next to Jerry, or it could be Jerry next to Tom. There's 2 ways they could be arranged. So we need to times that by 2. And we're looking for a probability. So we're looking for how many ways that can happen out of the total possible number of ways that these people could be arranged. So that's the calculation that we are going to do. 6 factorial. 6 factorial times 2 divided by 5040 gives us an answer of 2/7. Interesting answer. Right. Part 2. That's a lovely 3 marks, isn't it? The students consist of 3 girls and 4 boys. Find the probability that no 2 boys sit next to each other. Well, we know that there are 5,040 arrangements altogether. If there are 3 girls and 4 boys, well, let's think about how that means. If no 2 boys are next to each other, how are they actually arranged? Well, there's our 7 positions on the bench. If there are no 2 boys next to each other, it must go boy, girl, boy, girl, boy, girl, boy. And that's the only way it could happen, isn't it? That no 2 boys could be next to each other. It's actually a slightly easier question than have they say no 2 girls next to each other. That would cause us more problems because you know you could have those 2 boys the other way around and that would still count. But that's the only way it can happen if they sit in that arrangement. There's no other option. It has to be like that. So what we're now considering is if it has to be like that, how many ways could we arrange the boys as they sit down? They could be arranged in 4 factorial ways. How many ways could we arrange the girls? They could be arranged in 3 factorial ways, and we're dividing this by the total number of arrangements, which is still 5,040. So we're going to get 4 factorial times 3 factorial over 5,040 gives me 1/35. Okay, so it's 1/35 is the probability that that happens. All 3 girls sit next to each other. Okay, so this is back actually to a similar bit of thinking that we did earlier, isn't it? We're saying, as we do this arrangement now, what have we got here? We've got the 3 girls next to each other. So we're thinking of them as being one group. So let's think about it as having the 3 girls as one group, and then there are 4 other people. So we're imagining ourselves with 5 as our kind of units of people, the girls, and then the 4 others gives us 5. So we're dealing with 5 factorial. Within that 5 factorial, the girls could be arranged any way that we like. So there are 3 factorial ways that we can arrange the 3 girls within the 5 factorial that we've already got. And we're still dividing this by our 5040. Notice that because they've asked us for probability in every single case here, if you'd got this wrong at the start, they would have allowed you to have used whatever value you got for part 1 as your bottom line of your probability calculation. So, what does this give us? I'm just going to alter my last calculation. This gives us a 7th. Again, as our probability of that happening. There we go.